In this lecture, I'll be talking about a new library in Python named Numerical Python, which gives us access to another data structure, arrays. This is related to chapter 4 of our second textbook. The Numpy, read as Numerical Python, provides access to a new data structure called arrays, which allow efficient vector and matrix operations. It also provides access to a number of linear algebra operations, such as solving a system of linear equation, computation of eigenvectors and eigenvalues. Before we talk about different methods under this library, I would like to discuss the difference between an array and a list. List is one of the main data structure that we can organize data by position. So the main difference between a list and an array is the function that you can perform to them. For example, you can divide an array by 3, and each number in the array will be divided by 3, and the result will be printed. If you try to divide a list by 3, Python will tell you that it cannot be done, and an error will be thrown. If you are going to perform arithmetic function to your list, you should really be using arrays instead. And in this slide, you see an example just to understand the difference better. In the first part, we are creating a list. So we are importing two libraries, random and math library. And then we define an empty list. And I define a for loop to generate 10 items or elements in that list. So first, I generate a random number between 1 and 6, and then I use the append method to populate that list. And then we want to add 2 to all elements to that list, and we will see t plus 2, so we'll see the result. And now I want to generate the same number or the same data using Numerical Python. So first we import Numerical Python, and I assign np, the short version, as a nickname. So I call Numerical Python.random.randint, so the same function between 1 and 6. Then I pass the size. So it's like a vector, the size is 1 and 10. It means that we will see 1 row and 10 columns, which is very similar to the list that we have. And then we will see the result from x plus 2. So let's implement this in a Python notebook, and you can see what the results look like. First, we import two modules, random and math. I define an empty list. Then I write a for loop. So I want 10 items, which are randomly generated between 1 and 6. And then we apply the append method to add it to our list. So you can see that to generate 10 items, we do need to use the for loop. Okay. So we run this, and then we print t. So you can see it has 1 row and 10 columns. It's a list which represent a sequence of numbers. And let's say I want to add 2. So t plus 2 to all elements to that list. So for example, 5 plus 2, 3 plus 2. If we run this, and this is the error that you see. So this one is not defined for a list. Now let's do the same procedure, but this time we use the Numerical Python library. So we import Numerical Python, short version np. So I write just one line of code to generate 10 random numbers. np.random a random number between 1 and 6. I pass the size, which is 1 and 10. And then we run it. Size equal. Let's print x. So first off, you can see that it's an array. So the data structure is different. You see double square brackets. All are randomly generated between 1 and 6. And there are 10 items in x. Now, x plus 2. When you run this, you can see that this is applied to all elements in the array. So 3 plus 2 is 5. 1 plus 2 is 3. So you can see that you applied this function to all elements in the array. And that's the main difference between a list and an array. So hopefully with this example, you saw the main difference, and you can compare the lines of code. So to generate 10 items, we do need to use a for loop for a list. But here, technically, with one line of code, we generated the same sequence of data. And if we want to add 2 to all items in a list, then we need to write another for loop, which goes through all items in the list and then add 2 to those items. So that's why array is a useful data structure when you want to perform arithmetic operations. That being said, here you can see a few examples of how we can generate an array. The first technique, conversion of a list or tuple into an array. So there is a method named array which makes everything an array, just like list. So here we are passing a list with 1, 2, 3, and 4 items, and then if we apply array, then its data structure becomes an array. It means that if then you can, whatever the function is, it will be applied to all elements. So the first method is array. We can also create a vector using array range. So when we were dealing with list, we had a function range, which generated sequence of numbers between 2 upper bound, lower bound. We could also define the step value. It's the same function, but here it's a range. It's technically array range. So between 0 and 2, and then the step value is 0.5. But this one makes sure that the data structure is an array. We can also create vector with zeros. np.zeros, then it creates a vector with 4 items, all zeros. Once the array is established, we can set and retrieve individual values. Let's say we want to update values for x. The position of the first item by default is 0. Then you can assign the new value. So x0 then is equal to 3.5. x2 is actually the third element, and now it's equal to 4. Let's implement this in a notebook and you can see the result. First, we use the array method. First, we call Numerical Python np array, and then we pass a list. Let's say 0, 0.5, 1, and 1.5. If you print this, you can see it becomes an array, so it'll be treated as an array. We can also apply the array range function. So x is equal to np dot array range, between 0 and 2, and the step value is 0.5. Let's run this and you print. So you will see it starts from 0 at 0.5 and through 2. So a sequence of numbers, but the data structure is an array. We can also apply the zeros function. So x equal to np dot zeros. So how many items? Let's say 4. We add a comment. So here, vector with zeros. So you can see this array, this vector with 4 zeros. And now let's say we want to update values. X bracket 0 equal to 3.4. Then it updates the value. Let's print this, and you can see that the first item is now 3.4. So that's how you can access different items in an array or vector. Let's say x2 is equal to 4. Now you can see the third item. So the first one is 0, 1, 2. The third item is now 4. Note that once we have a vector, we can perform calculation on every element in the vector with a single statement. That's one of the advantages of using array as a data structure. So let's say we generate a sequence of numbers using arrange method. Between 0 and 2, they are evenly spaced by 0.5. And then we add 10 to all items. So we simply print x plus 10 or x raised to 2, or apply a function. Here we are calculating sign of x for all elements in x. So just with a single statement. If it was a list, we needed to write a for loop to go through all items in that list. So np.arrange between 0 and 2, a step value 0.5. Let's print x. And now x plus 10. It will be applied to all elements. So 0 plus 10, 0.5 plus 10, or x raised to 2. Then this is the result. 0.5 raised to 2 is 0.25, and so on. Or we can apply a function. So np.sign of x. And now that function is applied to all elements in the array. Now, so far we work with a vector. Now we can create a two-dimensional array, like a matrix, by converting a list of lists into an array. So one technique is to use a list of lists, and each list will become one row in your matrix. We still apply array because that makes sure that the data structure is an array, and then we pass list of lists, like in this example. Using the zeros method to create a matrix with 5 rows and 4 columns. So now if you want to specify the size, so you apply zeros. The first one shows the number of rows. The second one shows the number of columns in your matrix. And if you want to know the size of your matrix or the shape, then you apply the shape method, and then it returns the number of rows and number of columns for your data. So let's print and implement this in a notebook. So first, I create a two-dimensional array using list of lists. So np.array. The first list, let's say, is 1, 2, 3. The other list is 4, 5, 6. Let's print this. First off, it's an array, and you can see 2 rows and 3 columns. And let's create a matrix of zeros. So x equal to np.zeros, and we specify the size, 5 rows and 4 columns. If you print, then you can see that there are 1, 2, 3, 4, 5, and 5 rows and 4 columns. Let's say we load a data and then we want to extract its size. How many rows, how many columns? To do that, we apply the shape method. So x.shape returns the shape of your matrix. 5 by 4. That's what we created. So this shape method is very useful just to know the dimensionality in your data. Now here, individual elements can be accessed and set using this syntax. There are several examples. So we discussed how we can update values in a vector. Now we can update values in a matrix, but we need two input arguments. The first one represents rows. Which rows? And the second one is columns. So by default, the first row is 0 and the first column is 0. So here in this example, you see that we have a two-dimensional array. So it has 2 rows and 3 columns. And x0, 0, it means that go to the first row and the first column, and the value is 1. And here, 0, 1 means that go to the first row and the second column, and the value is 2. In this another example, x02 means first row and the third column, which is 3. Another useful syntax here is to get access to a specific row or column, and for that we use colon. So here you can see an example, x colon comma 0. So it means that we fix the column, it's column, the first column, and then we want to see all items, all rows. So here, if we fix the first column, we know that we have 2 rows and the values are 1 and 4. If you want to fix the row, like in this example, we fix the first row and then we want to see all columns, then it returns 1, 2, 3. So let's quickly run this and notebook. So this is our x. x0 and 0 we expect is 1. x0 and 1 should be 2. So it returns the value x0 or 2. See, it's 3. And if we want to fix the column, so we use colon, and we are interested in the first column, so I fix it, and then you can see 1 and 4. Let me print x here. So this is the first column over here, and there are 2 rows, so you only see 1 and 4. And if you want to fix the row, for example, the first x1, which becomes the second row, comma, colon. And then we see 4, 5, 6. So we just fix the row, and then we want to print all columns in that row. So that's how you can access different values in a matrix. But we can also apply matrix multiplication. So 2 arrays or 2 matrices can be multiplied in the usual linear algebra way. And here's an example. We generate random numbers, matrix A, and the size is 5 by 5. So here I'm using a new function, rand, which generates a random number between 0 and 1. Before we had rand int, which generated integer random number between 2 values. But rand just generates a number between 0 and 1, and then you can specify the size. So now the size of matrix A is 5 by 5, 5 rows, 5 columns. Then we generate another random numbers, but this time the size is 5 by 1. And if we apply the dot function, then it multiplies these two matrices. So let's implement this here. A is np.random.rand function 5 by 5. Let's run this and then let me print. So you can see it's an array. There are 5 rows and 5 columns, and they are all between 0 and 1. X is another random matrix, np.random.rand. The size is 5 rows, 1 column. Now you can see there is just 1 column and 5 rows. And then we can apply the dot function. So np.dot. So we want to multiply A and X. And the result is a 5 by 1 matrix. So you can multiply any two matrices that you have. Now here is a practice. So we just want to summarize the main points we discussed in this lecture and also play with the methods. So first we create an array called X, which its elements are between 5 and 20 and evenly spaced by 2. We also want to create the following array. So you can see that most of the items are 0. A few of them have values. Then we create an array called Z, which its elements are cosine of elements in array X. Then we create an array called R, and then which its elements are equal to elements of Y plus 10. Then we create a matrix called U, which has 3 rows and this 1, 2, 3, 4 columns. Then we create a 5 by 7 matrix, which its elements are random numbers. Another matrix called B, 5 by 2. And then we want to create matrix C, which is a product of A and B. So at this point, I encourage you to pause the video and try to create these arrays and matrices and then compare your code with mine. Okay. Let's create the first array X, np dot. So we want to generate a range between 5 and 20, and the step value is 2. So np dot arrange between 5, 20 and 2. They are evenly spaced by 2. Let's print. So you can see 5 plus 2, 7 plus 2 through 20. Now to create a vector Y, there are different methods. I would like to generate a zeros vector first and then update the values for elements whose number is not 0. So first I create zeros vector using zeros, and there are 20 items in that vector. And now I'm going to access those elements and then update their value. For example, and remember the position of the first element is always 0. So if you want to update the first element, then it's y3 equal to 6. Then if we print y, you can see that 1, 2, 3, the fourth element's value is now 6. Now y9 is equal to 9. y13 is equal to 12. And y15 is equal to 24. We run this and let's print y to make sure. So this array should be the same as the array we have in this slide. Then we want to apply the cosine function to elements of x. So I define a variable z, np.cosine of x. Let's print z, then it shows the result. We also have another array r, which is y plus 10. Just one single statement. We can run this. So y is 0, so 10 plus 0, and here 10 plus 6, you see 16, so it's applied to all elements. Then we want to create a matrix named U. So I use the array method and then use lists of lists to define rows and columns. The first one is 1, 3, 2, 4. The other list is 7, 9, 2, 1. And the last list is 3, 9, 1, 6. So don't forget commas between items in each list. Let's run it, and then when we print, you can see that it's a matrix with 3 rows and 4 columns. We can also apply the shape method to see the size, which is 3 by 4. Then we need to generate 2 random matrices. The first one A, np.random.rand function, which generates a number between 0 and 1. The size is 7 rows and 5 columns. Let's make sure this is okay. You can see 7 rows and 5 columns, and they're all between 0 and 1. Then we can generate the other matrix in the same way. np.random.rand function. The size is 5 by 2. With 5 rows, 2 columns. Again, they are all between 0 and 1. Now we can multiply them using the dot method. So C is equal to np.dot function applied to A and B. Now we can print matrix C, which is 1, 2, 3, 4, 5, 6, 7 by 2. And with that, we wrap up our discussion.